All right, so here we go. We've got a Tarzan-like problem here. We've got a dude up here on top of a cliff. Total height of the cliff is 15 meters. 60-kilogram guy is going to swing down on this vine, run into this 30-kilogram something, collide with it, and then the two of them will become one, and they will, as a group, fall down here into the lake. And the question is, where do they land? How far is this distance? Now, there's no doubt when you first look at this problem, it is a very intimidating looking problem. There's a lot of stuff going on. So what you need to do is really focus on what do you know. So for instance, I can look at this problem and be like, well, I'm scared, but this part of the problem when you're flying down into the ground, that totally looks like something I've done before. That looks like a projectile problem. And I can be like, hey, look, there's a collision in this thing. Because right here, they were separate, and now they're together. Well, I know anytime there's a collision, it has to be a momentum problem. That leaves this last section up here, where he's swinging down and about to collide. This is an energy section. So if you think about it first, you have a plan now. I'm going to solve an energy problem to find out how fast he's going right here just before the collision. Then it's a collision problem to find out how fast he's going after the collision. And now it's a projectile problem. So this is a sweet problem. It's a 3 for the price of 1 problem. So we look over here at the energy problem. And if we just look at that, you got a dude here, and he's going to be down here just before the collision. Apparently has 3 arms. He's got potential energy of gravity there. He's going to have kinetic energy here. So the potential energy of gravity is going to become the kinetic energy at the bottom. So mgh has to equal 1/2 mv squared. I think about it, this is the mass of the guy, and that's the mass of the guy, so those two masses can cancel out. So I've got 9.8 times 15, because the height of the cliff is 15, equals 1/2 times v squared. And when I solve that, I will prove, that v is equal to 17.1 meters per second. So up to, but not including the actual collision. So just right here before he's going to slam into this blob, maybe it's like a pile of fruit, he's going 17.1 meters per second. But now there's a collision. There is only one possible way to ever deal with collisions, and that's using momentum. So now you have dude here swinging, again with 3 arms, at 17.1 meters per second. And then after, when the package is just sitting there, and then afterwards you've got dude holding on to package. So you have no outside forces, no crazy jetpacks, no wall that you're going to slam into, no air resistance. So we've got momentum of our person plus the momentum of that blobby thing that we're going to run into has to equal the momentum of the person and the blob joined together. Mass times velocity of the person, mass times velocity of the blob equals their 2 masses together. Blob. So this guy's got a mass of 60 kilograms, it tells me, going 17.1 meters per second just before the collision. The package is going to pick up as 0. Now they're going to have a mass of 60 plus 30 because the guy's holding on to it, equals the velocity of both of them after the fact. Velocity of both of them after the fact, when I put this into the calculator, is 11.4 meters per second. Now I pause pause. I'm like, is that a reasonable number? It was going 17.1. The mass just got bigger. So yeah, it makes sense that he's going to be going a lot slower. There was a big force on him to slow him down as he pushed forward on the bag. Now, we're just back to a projectile problem. So, if you think of it as a projectile problem, you make your chart. You know the accelerations. You know he starts up 10 meters and lands on the ground. We're looking for how far he went. The most important piece is the hardest piece. Is that 11.4 meters per second is all in the x direction. And there is nothing in the y direction. Because when he flies off, he's right at the bottom of the circle. So he's flying off tangent to the circle. You've got 1, 2, a half, 3 things. So in the y frame, you can solve and you get t is 1.43 seconds. If you know the time, then you can do this problem all over again in the x frame. And you get 16.3 meters. So, the key to making these easy, think first. Every step of the problem is quite simple, things you're good at. You just have to put the pieces together.